Good morning to one and all. In today's lecture, we'll discuss about the probability, random variables, and random process. So, signal used in communication system are basically consist of two types. First is your deterministic signal, and second is non-deterministic or random signals. So, deterministic signal completely specify as a function of time. For example, your cosine function, that is AC cos 2 pi fct plus phi c, where your amplitude AC, fc and phi c is known. Now, coming on to the non-deterministic signals or random signals, it cannot be represented mathematically. That is, the future values cannot be predicted precisely in advance. For example, your speech, video, computer data, sensor signals, etc. So these types of signals may distort or interfere the signal, that is in the form of EM wave, electromagnetic waves. So the signal that interfere the transmitted signal in communication channel called as your noise channel, and these noise signals are additive in nature. So at the receiver side, the receiver receives a noisy signal, that is a combination of your transmitted signal or noise. Now, to describe in terms of its statistical or average properties, we use probability theory. So, we discussed the basics of probability theory, in which we see the concept of random variables and random process. Now, in communication system, we have two terms, that is your information as well as your noise. So the information and noise are known as your random signals. So these random signals can be measured and analyzed using a mathematical tool having statistical property that is further used to understand, that is the signal detection technique. Clear? Now, before proceeding further, we will discuss some points regarding the probability theory that is based on statistical experiment. First one, the outcome of a random experiment, that is known as your random events and random signal. Second, the statistical properties of random events that depends upon the outcome of any experiment can be obtained from the expectation operator. Third, for the analysis of your random signals, we use Gaussian random variable. Fourth, in the random process, in the study of communication system, the random process is known as your white noise, that is additive in nature. And the last one, that is the narrowband noise. So it can be viewed as in terms of your in-phase and quadrature component, that is the same as narrowband communication signal. So we have already discussed the in-phase and quadrature components. Now coming on to the probability theory. Probability theory consists of an experiment, that is the set of rules that govern the operation which is being performed. So in this, we perform the experiment once, that is known as your trial. When your trial is performed, we get a result after the trial that cannot be predicted precisely. These are known as your outcomes. After then, within the experiment, there are number of trials. After then, when we combine these results, we get outcome of every trial, that is known as your event. So within the experiment, there are number of trials. This whole procedure is known as your random experiment or random process. So the outcome may differ due to the random phenomena. For example, if you toss a coin, so the outcome may be a head or tail. So let us suppose that we toss a coin n times. So the desired possible outcome for head A will be occur that n times out of n. That is, the relative frequency of the occurrence of A will be Na upon A. Na is, that is the ratio of Na, that is number of heads, and n is the total number of outcomes in the event. We also say it as non-negative real number. Now, if we say there are two possibilities, if the head occur, and if none of the head occurs in the trial. So if the head will occur in the trial, then we can say that the ratio Na upon N is equals to 1. And if the event head occur in none of the trial, then it is known as then the ratio of Na upon N is equals to 0. So here we can say that your Na upon N is greater than equals to 0 and less than equals to 1. So here we note a point. If n is very small, that is the ratio of Na upon N is not predictable. So to find the certain result, your experiment repeats larger number of times. So when we repeat the experiments larger number of times, so in mathematical form we can represent it as limit n tends to infinity Na upon N is equals to your PA. That is the probability of head occur. And your Na upon N is the relative frequency of the occurrence of your head. Clear? So this was all about your random process and random variables. In the next, we'll discuss the axioms of probability. Thank you.